method. We were just zooming on the interval. We decrease the interval until we are satisfied with the limits. طيب, the bisection method, we said, we start with the interval. We make sure that the limits, the function, and on the limits have positive and negative values, right? Otherwise, if it has two positive or two negative, then we can see, or we can say, for example, in this region, the solution is here. No, not that. Here and there. The function here it's negative, and the function is there it's negative, so there is no solution. It must be between two limits with different signs for the function. Here it's positive and here it's negative. So what did we do? Every time we cut the interval into half, the name comes from bisection, right? So over here, the function has a negative sign. If that was A and this is B, which boundary should I move? I should move the A limit, right? So A becomes A plus B divided by 2. The midpoint becomes the new midpoint. طيب, if that is, after that, we cut the interval into half. And at that location, the value of the function is positive, isn't it? Can you see it with me, guys? Value of the function there is positive. So which limit should I move? A or B?
A.
A عادي كانت negative, صح? If I move A, then A will be positive and B will be positive, isn't it? Do we have a solution over here in this interval?
No.
No, we don't have A. So we cannot move A, right? So which boundary should we move?
B.
B. So B becomes A plus B divided by 2. We continue. We cut the interval in half. احنا معناته solution موجود هني. Let me zoom in a little bit more. We cut the interval in half, okay? And we see that the solution is negative over there at the midpoint. So which boundary should we move? A or B? Sorry, it's not this B. This is B now. B is positive, A is negative, and at the midpoint, the solution is negative as well.
We move A.
We move A. ليش شباب؟ لأن هني أصلاً ما في solution. Negative and negative, right? So let's do that a bit fast in MATLAB. So what did we do last time? We started with a function, correct? We started with a function. Okay, what was that function, guys? I had some documents. Let us take the function from here. Execute minus 10x plus 5. Okay, that's the function. F. It's a function of x and it says x dot q plus minus 10 times x plus 5. Okay. So first of all, let's plot this function. We said an easy way is f plot. F plots functions. Okay, that is the plot. Let us put the grid line, grid on. That is the grid line over here. There is one solution over here. There is another solution over there. And we have the third solution over there, right? So we have 3 solutions. So between 0 and 1, do we have a solution, guys? between 0 and 1. Do we have a solution?
No, because both positive.
Let's see. That is the line positive and
We have Victor. Negative.
negative. Okay, so do we have a solution?
Yes.
Yes, we do have a solution, right? Yes, we do have a solution. Okay, so we do have a solution. So let's take that those as limits for A and B. Let's define that as limits for A and B. So A is 0 and B is 1. So what shall we do? I will say that is limit A, that is B, this is f of A, and I want the midpoint as well, right? So how much is the midpoint? It is f at A plus B divided by
2.
2, and I need f at the other limit. Okay. So let's do that, guys. طيب شباب شو صار عندنا؟ That is f of A, sorry, this is A and that is B. This is f of A and that is f of B. At the midpoint في الوسط هني خليني ارسم لكم اياها مرة ثانية. At the midpoint between 0 and 1, over there, the value of the function is positive. So at A, it is positive. At B, it is negative. At the midpoint, it's positive. So which boundary should we move? Do we have a solution here?
No.
No. Both functions are positive. Okay? Or the value of the function, both sides are positive. Okay, so this means the new midpoint A equals A plus B divided by 2. فمعناته الحين the value of A as 0.5, right? Okay, so now let's repeat that iteration one more time. Over here, this is A, this is B, this is f of A, this is f of B, this is at the midpoint. So what shall we do?
Move B.
You move B, right? Then you also follow that. Okay, so في هالحالة B equals A plus B divided by 2. All right. Then we repeat that iteration. And we run this code again. This is A, this is B, F A, F B, F at the midpoint. Which boundary should we move?
B. A.
شباب فكروا فيها بهالطريقة. Over here, both the function and at the midpoint are negative and negative. This is f of B, that is f of A, that is at the midpoint. هل هذه negative or هذه negative? Do we have a solution?
No solution.
No solution. So the solution is somewhere there, right? Somewhere here. So which point should we move?
Point A.
B.
Point?
B.
B. Yeah.
Point. شباب اللي بس يسكر المايك تمام. Okay, so that is point B. Okay, so let's copy that stuff again and run that code again. على محل الشاشة هني. A, B, f of A, f of B, and f at the midpoint. Okay, do we have a solution? مرة ثانية, do we have a solution over here?
Yes.
Only the solution exists over there, right? So هذه كان this interval we get rid of it, right? So let's move this boundary now. isn't it? نفس الشيء. We move B again. We continue. That is A, f of A. That is f of B. This is f at the midpoint. What shall we do? Do we have a
B
solution?
again.
Move
This-
B, sir.
Move B. Okay. شباب بنواصل this exercise until the difference between A and B is up to certain limit. طيب, you need to know this stuff. This approach or this algorithm or this method is very slow and converging to the final solution. Yet, what is the good thing about it? You are guaranteed to have a solution. Okay, you are guaranteed to have a solution. Although it is very slow, but you are guaranteed to have a solution if you use this approach. Okay, if you use this approach. All right.
Victor,
No.
but what if there is no solution between A and B? If you start with
Then it will go for infinity. So for example, if we write a loop, all right, if we write a loop or a while loop, we have to make sure at the beginning of the code, f A multiplied by f B should be shabab less than 0 or more than 0?
less than 0.
Less than 0. And if this was negative and this was positive, then we know that there is a solution. So it should be less than 0. If that was negative and that was negative, it is more than 0. No solution. No solution. If it was positive multiplied by a positive function, it is again above 0. So we need to satisfy that condition first. F of A times f of B is less than 0, do blah 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 blah, right? Else, okay, we write no solution. يعني display no solution. End this code. واضحة الفكرة؟ And we need to write.
Yes, Doctor.
نعم علي.
Yes, Doctor. Wow.
Okay. And we need to while error is greater than certain tolerance, do the following steps, right? Do the following steps. And tolerance, شباب لازم, if we define a tolerance, we need to start with a value. Let's start with 1, for example, or 10, or whatever. Okay? But if you don't define it, the code will go there while error and tolerance is not defined. Okay? So we cannot do anything. Similarly, sorry, tolerance should be 10 to the minus, let's say, minus 3. And you have to define the error. Initially, you have to initialize the error. Error, let's say 1. And 1 is more than 10 to the minus 3. Okay, the code will start. All right? So that is the bisection method. Right. Can we move on to another approach? Is that clear, the bisection method and the increment search method? No answer.
Clear.
Yes, Doctor. Clear.
At least 2 people. All right. Okay, this approach, this scheme is what we usually use for solving nonlinear problems. Right. Picture 10. Okay. So what do we have? We will start with Taylor series expansion. طيب. how many of you studied Taylor series expansion? So, did you study Taylor series expansion?
على السريع كان دكتور يعني بس نسينا كالكولاس 2 نهايته.
Calculus 2. طيب. Can anyone tell me why do we need Taylor series expansion? Or what is the essence of Taylor series expansion?
To evaluate integrals that we can't using the other methods.
Okay. طيب. شباب, suppose you are at point xi. And at that point, you know the value of the function at xi. All right? And suppose, guys, you want to find the function, the value of the function at point xi plus 1. So at that point, xi plus 1, you want to find the value of the function over there. Using only information which is available at that point. So Taylor series expansion says, if at xi plus 1 is known, you can evaluate it or you can find it if you know the following. If you know the value of the function at xi plus 1 plus xi plus 1 minus xi, basically that distance, all right, multiplied by the derivative at xi. So basically that is the first derivative, the slope over there, plus the same distance, xi plus 1 minus xi divided by, or square divided by 2 factorial multiplied by f double prime xi, okay? Plus the same distance to the power 3 xi plus 1 minus xi to the power 3 over 3 factorial multiplied by f triple prime, okay? Plus what? What shall I write next? What shall I write next? Plus the same distance, xi plus 1 minus xi to the power 4 over 4 factorial, okay, f 1, 2, 3, 4, xi plus, and Shabab, this continues, isn't it? This is a series, right? Which means it goes to infinity. Okay? It goes to infinity. So,
Yes, sir.
in case, I mean, you cannot go to infinity, right? You cannot evaluate it numerically to infinity. You don't have the computational power to continue forever. So what do we say? We say that we will truncate the series. We will cut the series. Okay, we'll cut the series over there. So I will ignore all the terms that comes after that. I will truncate it. I will cut the series. So plus what? Plus something of order xi plus 1 minus xi to the power 5. So this is called, Shabab, truncation. Truncation. Basically, you are cutting the series, and you know, for example, let's say, Shabab, that distance is 0.1. Yani xi was, let's say, 1, and xi plus 1 was 1.1. So that distance is 0.1. So 0.1 square is 0.01. Then 0.1 to the power 3, that is 0.001. Then 0.1 to the power 4 equal to 0.0001, right? And as you are going in that direction, this term is getting smaller and smaller and smaller, which means what? Which means its contribution is getting minute and minute. أهمية التير the other terms شباب اليونت next to the elements that you have previously is getting smaller. واضحة الفكرة؟ That's why you will say, okay, you know what? It's not very important to include them لأن أصلاً القيم قاعد تصغر. Okay, so I will truncate the series and I will cut the series, and it has something. O means order. Okay, it has little bit of error. Why? Because I did not include all the terms up to infinity, but I will truncate it and I have something of order h to the 5. What is h? H is basically that distance. Is that clear? So I will define h as xi plus 1 minus xi, all right? And let us rewrite this Taylor series expansion. Taylor series expansion now becomes xi plus 1 equal f at xi plus what, guys? Plus h multiplied by f prime at xi plus h squared over 2 factorial multiplied by f double prime at xi plus h cubed over 3 factorial multiplied by f triple prime at xi plus, okay, if I want to stop over here, what shall I write? What shall I write?
Plus O.
O, something of order.
Order of h to the 4.
Exactly. Okay. Some error, some terms which has the order of h to the power 4. Okay, so that's the Taylor series expansion. Right. Okay, all right. So guys, now
Doctor, I have a question.
تفضل.
What if the derivative equals 0, the third derivative? Maybe it's a quadratic.
زين.
Yes.
Okay. So it means it has no contribution.
So we add. We should add the truncate or not?
ما لها قيمة. Even if you added it, it has no value.
Okay.
Now let's bring what we have from Taylor series expansion to solving a nonlinear problem. Suppose, guys, I have the following case. Suppose I have the following function. Okay, I need your attention for 2 minutes. لأن الجزء مهم حق الجزء مهم شباب حق Newton-Raphson method. By the way, did I write that? Yeah, this is the Newton-Raphson method for solving nonlinear problems. طيب, what do I have? Let's say, guys, I'm at that point xi. And what is the value of the function at xi? That is fxi. Okay? Guys, at that point, what does it represent بالنسبة لنا in the non-linear?
A solution.
Exactly, that is xs. That is the solution, right? Why? Because f of x equal to, we said equal to 0. The right hand side now becomes 0. So what is x that satisfies that condition? So that x بالنسبة لنا, that is the solution. All right, which means f at xs equal to 0, isn't it?
Yes, Doctor.
Okay. Right, so let us rewrite the Taylor series expansion. F, that is fxi plus 1, which equal f at xi plus h multiplied by f prime at xi. And I will stop over here. I will truncate the series over here. So what shall I write? Something of order h squared, isn't it?
Yes, Doctor.
Okay. Okay. Suppose that point, that is point xi, and that point is xi plus 1. Suppose that point was the solution. Suppose that point was the solution. So I will write it as f x s, okay, which equals, what does it equal to, guys?
0.
0. الحين بكتب الكلام هنا. اكتب equal to f x I, all right, plus h. What is h, guys? What is h?
The difference.
The difference, which means
XS.
xs or xi plus 1 minus xi, اللي هي xs قلت عنها علي, multiplied by f prime at xi, isn't it? Plus something of order h squared, okay? طيب. Okay. Guys, what is the unknown point, or what are we looking for in this equation? طبعا هاي صفر خلاص هاي صفر.
We're looking for XS.
And this equation, what are we interested in? مو هالنقطة، ما نبي نشوف السوليوشن وين صاير. Isn't it? عبد الله، أنس، أحمد، علي، عبد الله إبراهيم، أنور، علي حسين.
وياك دكتور.
Okay. That is the point that we are looking for, right? Can I solve for it? Can I solve for it?
Yes.
So let us rewrite it as, let me take that xi to the other side. So that becomes f xi. All right. Which equals what? Or you know what? Let's, yeah. So that thing equals to xi plus 1 minus xi multiplied by f prime at xi. Okay. So can I divide by f prime?
What about the O of H square?
خلاص, we are ignoring that, right? We are truncating the series. So basically, it means we are ignoring it. Adil, Ali?
Okay.
Okay. So what do we have now?
minus f over fi
عبد الرحمن, xi plus 1 minus xi multiplied by f prime at xi, which equals what? Equals minus f at xi, isn't it? Correct? If you divide by f prime, so xi plus 1 minus xi, which equals minus f xi divided by that term.
prime.
By f prime at xi. Okay. Okay. Then what is the unknown quantity?
Add xi.
So x. Okay. Let me give myself a little bit of space. Xi plus 1 becomes what? Take this to the other side. Xi minus f at xi divided by f prime at xi. Okay, so guys, what is that now? This is a Newton-Raphson iteration or scheme. That thing is called Newton-Raphson scheme. Okay, that is a Newton. Okay, so physically or numerically, what is happening? Suppose I have the following case. Suppose I have the following function, and let's say I started at that location, that is x1, that is the initial point. So over there, that is the value of the function. That is the value of the function at x1. So if I come over here and I do that step, I find basically the slope I find this. Okay. Let's say I found the slope. And I took x1 minus f x1 divided by f, the slope at x1. I do that step, I will land at point x2. So that Shabab is x2. So now I am at x2. What shall I do in order to find the solution? I will do another iteration. That iteration, if I say x2 minus, let's go up, that is f at x2. Let's take the slope and let us evaluate the function at x2 divided by f prime at x2. We'll evaluate that term. This gives us what? What does it give us? x3. That is x3. Okay, do we have the solution? No. Still, the difference between the function and 0 is quite large. So what shall we do? Let's go over there and at x3 minus f at x3 divided by f prime at x3. So guys, if I do that, let me say I landed at x4. This gives you x4. You will see, for example, in this case, that f at x4 is very close to 0. So what do you conclude?
We'll stop the iteration.
So basically, that is the solution. Shabab, تشوفون why I'm saying this is an iterative method? Okay.
Yes, because you need multiple steps.
We need multiple steps in order to get the solution. Okay. Let me stop over here, and we will continue after the break. طيب. I'll see you inshallah few minutes. يلا مع السلامة.